Good morning, DDDPerth. What an amazing keynote, and welcome to the first breakout session in the Riverside Theatre. So, my name is Rob Crowley, and I will be your room coordinator for the day, so yes, you'll be hearing quite a lot of me. Apologies for that. It is actually my massive pleasure, for the second year in a row, we worked out well, to introduce Mandy Michael to the stage. So last year I got to introduce her functional HTML talk, and this year she's promised us something incredibly special with browser sensor APIs and a pretty amazing demo as well. So without further ado, Mandy, welcome to the stage.
Awesome. Hi everyone, welcome to DDD. Special thanks to all of the sponsors today who made DDD possible. There are like so many of them. It's really great that so many companies, particularly Perth local companies, are supporting the conference. The clicker isn't working. It was working a second ago. There we go. My name is Mandy Michael. I'm a front-end developer and the development manager at 7 West Media here in Perth. I like to experiment and to tinker with things on the web, so that's kind of what we're going to have a look at today. My passion is experimenting with different front-end technologies, new and old, to see how we can combine them and create some cool and exciting things. So that's what we're going to do today. We're going to look at some fun stuff we can make with sensors and browser APIs. Specifically, we're going to look at three things. We're going to look at speech recognition, device orientation, and the ambient light sensor. But before I get into showing you some stuff, I want to make a couple of things really clear. I have to be standing right here for the clicker to work. Thing number one. What we're going to be looking at today are fun experiments. I'm not going to show you anything particularly serious with it. The reason for that isn't because you can't, it's just I wanted to make some fun demos because I like to tinker. So I'll talk about some fun things that you can do, but the stuff I'm going to show you is just going to be some fun examples. The other thing that I wanted to mention is that some of the examples that I'm going to show you are going to have great browser support and some not so much. I'm not really going to go into a lot of detail about browser support. I will show you on the next slide a legend of what the support is. But what I'm hoping that you do is try not to focus on that kind of stuff. Take a step back and just enjoy and listen and maybe be inspired about the kind of things that you could use this for in your projects now or in the future. Pretty much everything on the web started out as an experimental technology, so we need to start figuring out how we can make use of this now. So this is the support legend. At the beginning of each section, I'm going to put up on the slides some browser logos. A full logo means full support. If there's a flag, it means you have to enable a flag. And if there's a star, it means it will be fully supported in the next version. So from this point on, I'm not going to mention browser support. You can go check it out on caniuse.com or their MDM docs, but keep an eye out for the logos as we go through. So we're going to dive right in, and the first thing we're going to look at is web speech APIs. The web speech API basically enables you to incorporate different voice data into web apps, and it's split into two interfaces. There's a speech recognition API for recognizing audio and turning it into text, and then there's a speech synthesis API, and that turns text into a computer-generated voice. What we're going to look at today is specifically speech recognition. The APIs are similar, and you can share a few things between the two. But if you want to go and check out more about speech synthesis, I'd highly recommend you check out Mozilla's docs. So at this point, we're going to try using the internet, which is bold. So I want to show you what speech recognition looks like. Hello DDD, my name is Mandy. I have to lean right in for it to work because it's so echoey in here. So what we're doing is speaking into the microphone, and then the speech recognition API is trying to determine what it thought I said. And you might have noticed some of the words were changing as it read out. That's because it thought I said something, then it got more context, and it changed to get a more accurate confidence rating in what I'd said. So I'm going to show you how to make this because it's pretty straightforward. There's not a lot needed. This is where I'm going to show you some code. There's not a lot of code required to make this work. So So don't worry about it if you're not a developer. I picked up the wrong clicker. So this is the first thing that we're going to need. We're going to need to make use of the speech recognition constructor. And what this is going to do is create an object instance that gives us access to all the APIs, methods, and properties. There are a few of them for speech recognition, so I'm going to keep it really simple and just show you the ones you need to make that specific example. The next things we need are a couple of methods, start and stop. They pretty much do what you'd expect. They start the speech recognition service, and they stop the speech recognition service from listening to incoming audio. The special thing about stop is that, along with stopping it, it also attempts to return a result captured from the microphone. We're also going to need some event handlers. Most of them simply listen for changes in recognition status. So the two I'm going to focus on are onResult and onSpeechEnd. So onResult will run whenever a word or phrase has been recognized. And this basically happens every single time it hears the user speak a word or several words in quick succession. OnSpeechEnd, what this does is just run when the service has stopped being detected. It's kind of like if you pause for any length of time, that's when this is going to fire. Now the last thing, this is going to be the most complicated thing I'm going to explain to you all day, so that this is going to set the scene for how fun the rest is going to be. The speech recognition API is a little bit complicated in that it can return multiple results and multiple options of those results. So what happens is we can get the result list, the speech recognition result list object, and that has the speech recognition result object, and that has the speech recognition result alternative, which is a little bit confusing, but as I say, because the speech recognition API can return multiple results, it kind of needs a few ways in which you can access things. For the purposes of today, we're just going to get one result, and we're going to focus on the speech recognition alternative object, which is where the transcript for the text that it thought it heard from the microphone lives. So in our code, it's going to look like this. We have our list object, we get the first result alternative, and then the transcript. And we can throw that all together into a function. The only extra thing I'm doing here, aside from using what I've already shown you, is looking for a div on the page, or actually not a div, a paragraph, because that's more semantically correct. And then I am updating the content on result to pass the result of my speech recognition object into there. That's it. And that's how I made that example. All this code is all you need to do that. So you can see that it's really simple to get started with using speech recognition API. But if you want, you don't have to just print text out on screen. You can, do something a bit more fun. Like this. This is my dog friend. I love dogs. My dog's name is Jello. This is my dog's alter ego, Mello. Who's a good boy? He's a good boy. So all I'm doing with this is detecting for a specific phrase. And when that phrase is detected by the speech recognition API, I'm changing some divs on the page in my SVG and also animating the tail. He also does, where's the ball? Oh, no, keep the wrong button. Where's the ball? And he looks away. So there's like a bunch of things that you can do with this. You don't have to just think about it in terms of printing text out on the screen. What I think is really interesting about it is that it's going to allow us to create more interactive and more accessible experiences. If you think about the fact that not everyone is going to use our computers and our websites are using a keyboard and a mouse. Sometimes people might be using other kinds of inputs, and we can provide that with different aspects of our websites. I had a conversation with someone at my work about using speech recognition to allow people to search the page. Maybe you want them to be able to stop and start video or navigate between your page with speech recognition. There are a lot of opportunities there. So the next thing that I wanted to talk about was device orientation. So Most of our web-enabled devices have something like a gyroscope or an accelerometer, and that can determine the device's orientation and return some information on that. It's commonly seen in things like mobile devices to automatically rotate your screen to the right way up. I really hate that, so I turn it off, but that's where you see it a lot of the time. And it's just going to allow us to access that information about the device. In order to use that, like speech recognition, we need a couple of things. The first is the device orientation event. And this provides the information on the physical orientation of the device that we're using. And from that, we can then access a few properties. Specifically, there are 3 called alpha, gamma, and beta. And they return different number values depending on the device's orientation. So the first one is the alpha property. And this is basically the direction that the device is facing. So if you think about it, it's kind of like turning it around in a circle, much like a compass. It has a range from 0 to 360. The second one is the beta property. And this represents tilting the phone forwards and backwards. And that has a range of minus 180 to 180. And then the last one is the gamma property. And this is represented by tilting the phone left or right, and is a range of minus 90 to 90. So in order to use it, the first thing we have to do is check that we have access to this information, so we can just see if it exists in the window. If it does, we can add an event listener of device orientation, and then we can pass a function in. This is an example of one super simple. All I'm doing is getting the gamma event property. If it's minus 50, I'm going to do something. And this code is specifically how I made this demo. As you can see, my phone is cracked, probably from playing with device orientation and not paying attention. Not really, I drop my phone all the time. All I'm doing here is as the phone tilts and reaches a negative 50 gamma value, I'm just updating the CSS of my text and throwing it all into the side of the screen. This is also a variable font, so it also tilts based on the gamma orientation, but there's a lot of simple kind of interactive things that you can do with that. Another example, which is text effect based, because if you don't know, I like to make a lot of text effects. This example is one that I use a lot in my text effects presentation. It's called a split vertical layout. I use it to demo simple text effects. What I'm doing here is using the orientation of the phone to move the position of the background gradient so that it shifts along the text. All I'm doing is using that code that I showed you before, but passing the value of the gamma property through to the gradient percentage. You could also do something like this. I took this SVG off iStop, broke it up into parts. I moved the water and the moon at different instances. Unfortunately, I can't show you that live because you wouldn't be able to see it. What I think is really interesting about device orientation is we see it a lot in things like augmented reality and games, and these days also some subtle UI effects, most commonly parallaxing type effects. But for me, what I think is really exciting about it is it allows us to create more interactive experience that's shaped by the user. Right now, a lot of our interactions are like hover, predetermined animations, people might click somewhere, but that's going to happen exactly the same way for every single person that uses our web app or our website. Device orientation and the speech recognition API gives our users the opportunity to change that experience and to create something that's specific just to them. It gives them more control over the experience that they're having. If you're doing branding sites or advertising sites and you want them to each user to have a different experience, these are the kinds of things that allow you to do that. If you are an artist or a designer and you want to express yourself differently to every single person that comes to your site, you can do that with these kinds of events. And that brings me to the last one, which is my favorite. I like to experiment with the light sensors a lot because I think they're the most interesting and the most versatile of the sensors on the web. And basically, the ambient light sensor is a photodetector that's used to sense the amount of ambient light that's in the room. It's pretty much found in every mobile device. Laptops have it, my laptop has it, TVs as well, you might see it. Commonly, it's used to do something super practical, which is to dim your screen in low light environments to take the strain off your eyes. TVs will also use it for similar reasons so that you can get see blacker blacks and that kind of stuff. So much like the other examples that I've shown you, we need a couple of things, and we don't need a lot to use the ambient light sensor. First, we need to create a new instance of the ambient light sensor, and what that's going to do is give us access to all of the information about the light in the room. We're going to need a couple of event handlers. Specifically, we need on reading. This isn't actually part of the ambient light sensor API. There is a generic sensor API spec that a lot of the sensors that you can use on the web use. On reading is part of that. And all it does is call whenever a reading is taken. The reading frequency for the ambient light sensor is determined by you. You can pass an optional property to the sensor's constructor, and that will tell you how many readings per second to take. For the purposes of today, we'll just take all the information it wants to give us. The last thing we need is to return the current light level of the room. The only thing we need for that is the illuminance property. And this returns a lux value, which is just a number value representing light. But we don't really need to worry about that too much because you can figure it out based on how bright it is or how dark it is. This is all the code that we need in order to do something with the ambient light sensor. I'm checking that we have access to ambient light to start with. I'm creating a new instance. I'm looking for a reading. And then if it's less than 20, I'm going to make the background black. If it's more than 20, I'm going to make it blue. That's all we really need to do. So it's pretty dark in here. So let me show you an example that I have made. Where's my mouse? There he is. So this is my moon. Let's see if it works with my Batman torch. It's quite, the lighting in here is a bit weird, so I might need to use my phone. Oh, there we go. So depending on how bright it is in the room will depend on what you see. I really love that I got to use my Batman torch. It's like the best day ever. So you can do all sorts of things with this, right? Again, like I was saying before, oh, hang on, wait, no, I want to be over here. Where's my mouse? I've also got this one. For those that don't know, I like to make an experiment with variable fonts, and this is a variable font. This was the first demo that I ever made with an ambient light sensor, and what it does is, depending on how bright it is, get my trusty Batman, will depend on the weight of the font. This is a cool font, it's called Tiny. I like it because it really demonstrates like super brightness. But what is really cool about this to me is that with variable fonts, because you can control the axis and the style of the font depending on various kinds of inputs, whether it's from your CSS or from your JavaScript, if the room is really dark that the user is in, much like they dim the screen, you might want to increase the weight of your font to make it easier for them to read. In the instance of my sun and moon, if you are in an experience where you're writing a story or like let's imagine for a second you are writing a story about a path and you're walking through the forest and it's in the middle of the day, so it's really super nice, but then they come back and look at it at nighttime and it's all spooky and there's owls and it's really dark and it's scary. You can do this and you can give your users different experiences depending on the situation that they're in. And I think that is the coolest thing, because at the moment the web is like a level above print on interactivity. But this kind of stuff lets us take it to a whole new place. Oh, I keep picking up the wrong clicker. So to finish up, what I wanted to say is don't be limited by what we can already do on the web. The web is a really, really young place, and there's still so much for us to create. And what I hate seeing is people going, oh, no one's ever done that, so it can't be done. That's not true. Sensors and APIs, these are the opportunity for us to create something new and exciting that nobody has ever seen before. And everyone in this room is capable of doing that. You don't need a lot of code to get this going, and you don't need a lot of experience being a developer in order to do that. To be honest, I think most of it is just creativity. So there are a couple of examples I wanted to finish up on that combine these APIs. This uses the ambient light sensor, so if it's bright in the room, it will show a spotlight on the text. Oh no. I think Keynote might have just crashed. There we go. What's going on? There we go. So if it's dark enough, if it's bright enough, you get the spotlight and you'll get to read the secret message that's there, but you have to use the device orientation in order to do that. So this is me getting rid of the light, and it disappears. So that's kind of fun. It's like puzzle games, and it requires multiple inputs in order for you to complete the task. So another one that I've made, which you might have seen on Twitter, I just wanted to show you what the orientation looked like. So you can move this UFO around, but I wanted to show you it for real so that you believed me when I said it worked. Got my little UFO. So because I can't show you the orientation on my laptop because it doesn't have a gyroscope, but I can show you the beam. So you turn the light on, yeah, I bet you know what's coming. So let me just get into position here. Got to click. Commence abduction. It didn't work. I moved. I got it. So this will only work if the beam is on, if it's over the cat, and you've said the words commence abduction. If that fails, you cannot abduct the little kitty cat. So kind of think about what you can do, think about the fun experiences that you can have with this, and think about ways that you can use this to create these fun experiences for your users. Thanks very much.